All right, Python Web Conference. We are back here on track 1 of day 5. I am joined with Moshe Zadka, and he's going to tell us all about the caching best practices, which I think is computer science problems. This is one of them that ranks right up there, is cache invalidation and caching. So I look forward to the talk. I will turn it over to you, Moshe.
Hi, everybody. So pleased to have this chance to talk to you and get to share with you the things I've learned about caching best practices. As the intro said, yes, this is one of the hardest problems and also one of the most important problems, right? I am not going to talk about naming enough by one, so I'm definitely going to be way up there. My name is Moshe Zadka. My website is cobordism.com, where you can find every way of getting in touch with me known to humankind. Okay, I want to start with an acknowledgement of country. I live in Belmont, which is in the San Francisco Bay Area Peninsula, and it is the ancestral homeland of the Ramaytush or Loni people. So there's different definitions for a cache, and if I talked about all the different ways of caching, this talk would be like about 5 hours long, and I don't have 5 hours. So for the purpose of this talk, I'm going to talk about network caching services. So key value stores that are in memory, not persistent, so that can go away. But while you put it in, there's a good chance it will survive for a while, and we let you not have to refetch the data or recompute whatever it is that you're computing. So this is what we're going to focus on for cache, because if you're writing a web service, there's a good chance you use one of those. And there's a good chance that you are not doing the best way, that you're not using it the best way you can. So a cache is not reliable. If you put something in it, you cannot count on having that thing after that, right? It's a cache. It might go away for like any kind of reasons. And you definitely don't want to use it even as an unreliable communications channel. It is really badly suited for the purpose, right? You want to use a cache as a cache. And if you get one thing out of this talk, is that when you have a cache, the first thing you need to do as a best practice is to only use it as a cache. If you want a reliable data store, use some kind of database, NoSQL, SQL, whatever. If you want to use communications channel, you can either do direct communications, or you can use like some messaging or a queue service. Use the cache as a cache. Honestly, like I put it in the beginning, because if you get one thing off the talk, that will be it. But hopefully you're already using your cache as a cache. That is reasonably common. So let's move on. Why even use a cache, right? Like theoretically, you don't need a cache, right? By definition, the value might not be there. You'll have to still write the code to compute it. So why not always compute it? One reason is latency. The computation might take a long time. Maybe it's okay to hit it occasionally, but you don't want to hit it too much. Do note that when you use a cache for latency, it does change your variance, right? Now your P90 or your P95 might be very different from your P50, because your P95 is where you're seeing the latency misses. So it does mean that not only you might not be actually solving your latency problems, but you might be making them harder to detect. But occasionally, like you are doing the right thing and you cache and like you get whatever kind of latency reduction you want. So if your computation takes a long time, then that's a good reason to cache. The other reason to cache is resources, right? You might want to avoid taking up resources and having an expensive computation. I want to be very clear that these are different things. And the reason to be aware of why you're doing it is because you first have to consider why you're using the cache to make sure that it's a good decision. And then if you're using it for resources, your usage profile might be very different if you're using it to reduce latency. So those are kind of abstract terms. Maybe I want to give an example. So if you have something like retrieving a username from a different data center, that might be slow, right? Going to that other data center might take like some SSL negotiation. It might take a latency, but it's probably not expensive. Retrieving the username by user ID is probably a very fast query on the data center. They could probably serve it up all day, and it would barely be a blip in the research usage. So you're not saving any resources on the remote data center, but you are going to be improving the latency quite a bit. On the other hand, if you have an index DB join, those things can be scary fast on modern databases. Modern databases are actually pretty good at keeping stuff in memory and doing all kinds of hacks, right? Literally, like they have whole teams optimizing that stuff. The index DB join might be almost as fast as a cache. On the other hand, you have a small amount of database servers, and if you go to the database server for every time that you need this database join, you might be taking up too much of the database resources. Eventually, other things that need the database for other reasons might not have it. The database might start suffering hiccups. So you notice that these are very different use cases, and you're using the cache for different users. Some users are both for latency improvement and for using less resources. But then again, you want to be very aware that you are doing it for both reasons, and you want to think whether it serves both users equally. And you might want to have a two-step thing. Again, like there's all kinds of consideration here. And the first thing is like be really aware why you're using the cache. And if I said that the first thing is pretty common, this is actually pretty uncommon, even though you think that it is straightforward. Again, if you remember two things from the talk is to think before you start using the cache and to think why you're using the cache. This is possibly the most important best practice. If you remember that, then everything else I'm going to say, you can eventually figure out from first principles. But if you don't remember that and you're not sure what problem you're solving, none of the other things are even important. Again, I want to be concrete because I don't have 5 hours. So I'll choose the most popular cache I know, and definitely the stuff we used in like the last 4 or 5 times I was in charge of caching in different companies, which is Memcache. It's super popular. And part of the reason it's popular is it's fast. It does exactly one thing, which is caching. It does not try to be a database. It does not try to be a communication channel. It does not try to be sometimes persistent. It doesn't try to be anything but a cache, which means it's easier to operate because you know what you're trying to achieve. And it's easier to use because you know that nobody else is going to take advantage of it for a different use. And because of that, I'm going to focus the talk on Memcache. This is basically like how would you use Memcache in Python. There's a few libraries. I chose to use PyMemcache as kind of like my example because it's pure Python. It's very clear what's going on. And these are like the 4 operations that if you're using a cache, you'll probably use. There's a lot more operations that Memcache allows. Honestly, 90% of the time, you're not going to use anything other than set, get many, and delete. All these 4, however, you will probably use in almost any realistic example. Okay, so what is kind of like the life cycle of a key, right? So you start by setting it, right? Until you set a key, you can't do anything else. Then hopefully you'll get it. Note that the get is optional. You might be surprised, right? Like someone might retrieve the username by user ID for some user, and that user, goes away, decides to take a swim or something, and like that user ID to username cache will never be used. This happens. This will happen some of the time. The question of how much it happens is important, but this is something to be expected, and eventually the key will go away. 3 of the ways that it can go away is it to expire. You can specifically set a key, and it is actually a best practice to set the key to some maximum time limit. If you think it's not going to change, for example, usernames don't change, right? User ID to username mapping is probably reasonable to keep for a while. You can say, an hour or even 12 hours, but you do want to keep an upper limit because that makes sure that like you don't leave junk in the cache forever. You can explicitly delete it, right? So you can say every time someone changes the username, I'm going to go and delete any potential user ID to username mapping, and it can be evicted. Eviction is a bit more subtle, so I want to very clearly explain what goes on with eviction. As I said, Memcache is very careful about saying it's pure memory. Now, memory is a finite resource and often strictly constrained. In fact, if you think of it in terms of paying for cloud resources, which is the way most of us run our environments right now, that's basically going to be the biggest part of the cost for the Memcache servers, right? How much memory you're going to put. So you're going to put the minimum amount of memory you can get away with, because nobody, it may be a bit more, but definitely not a lot more, because you're paying that money, right? And nobody likes to spend money. Which means that evictions will sometimes happen when you get the limit and Memcache says, well, you gave me 2 gigabytes. I'm already using 2 gigabytes. Someone asked me to cache something else. Something has to go. Memcache has all kinds of algorithms. You can configure it, but it doesn't matter. Something has to go. Some key will get evicted at that point. There's all kind of other, it's not just, kind of pure memory, right? The memory is divided into pools. So even if the Memcache as a whole still has memory, sometimes things will get evicted, but evicted basically means Memcache decides that it can't keep everything. Something new came in, so something that already exists has to go away. So Memcache, you'll often do some kind of, you'll put some kind of router in front of the Memcache. The best metaphor, if you haven't dealt with something like that, is think of it like an HTTP proxy. It sits in front of your Memcache and does request routing, but it's a little bit different because Memcache is a little bit different from web. The 2 most popular examples that are used in practice are Microrouter, which comes from Facebook, and Twin Proxy, which, as you might guess, comes from Twitter. They do pretty similar things. Microrouter is slightly more popular, and I'm going to focus on that. But you don't have to use a router like that. But if you don't use a router like that, you're going to have to use Memcache client-side routing. And the reason why you need either a server router or a client-side router is because, again, this is 2021, and among the many other things that are correct about this timeline, you don't want to be dependent on one server, right? You don't want to be in a case where your single Memcache goes down and suddenly everything you have is hitting the database. Your database is probably going to fall over in 5 seconds after that. So that means you want to have multiple Memcache servers, and you're going to have to route to them some way, right? You can put a server router, or you can make the client say, I'm going to choose a Memcache server based on the key hash, or there's all kinds of algorithms. But that makes the client responsible for 2 things. It's supposed to detect server outage and failover, right? Because that's why you have the client, right? So it has to decide when to give up on a server and when to start talking to a different server. That decision is best kind of kept as coordinated as possible with other clients. You can't coordinate explicitly because that would be really complicated, but you can at least try to use similar algorithms. The reason why you want to make sure that failover happens for all the clients in a similar way is because otherwise you'll get spurious cache misses. If I think this server is alive and you think the server is not alive, then if I set to this server and you won't see it on this server, and you'll get a spurious cache miss. So you want to have some coordination, and it means the client is also responsible for the fair sharding of keys, which means you have to carefully configure the client. Usually that's annoying, right? You basically have to start diving into the application code to make sure that it configures the client-side routing well. So a lot of people prefer to use server-side routing. That is definitely the solution I'm seeing more and more, even though all the Memcache libraries do support client-side routing. So routing is necessary. It's necessary because you want redundancy. It's necessary because you want scaling. It's much cheaper to have several servers, each with it's the upper limit, right? With say 20 or 100 gigabytes of memory, than to have one server a terabyte. And especially if you consider that you probably want to have some redundancy around that, and it's much cheaper to scale at least a little bit horizontally, and you want redundancy. So routing is not optional. You can do it as a client, you can do it as a server, but someone has to route. And For this talk, I'm gonna mostly, like I said, focus on Microrouter. So if I want to kind of remind you like the 3 points that I made so far, you use cache when you want to optimize latency or resources or both. Keys can vanish at arbitrary times, and routing is not an option. Definitely not in 2021. It might have been an option. It might have been only option in 99. We're not there anymore. So this is kind of a typical caching tier. And again, I want to make my talk concrete about how to use caching. So let's just have this example, because again, like I've seen this example in like a few companies. This is a very popular setup. You have a Microrouter layer. So Microrouter is stateless because it does not have keys. So that means you can do something like either a TCP or DNS load balancing in front of the Microrouter, which means if a Microrouter goes away, you automatically fail over and you don't have to worry about that. And then you put the Memcaches layers, and the Microuters make sure that they coordinate on which Memcaches are alive or not. That's quite a bit easier to achieve. And this gives you a good tier, right? Any server can go away, right? Any DNS, like DNS, you can achieve with something like Skynet or Console, or you can do TCP-based stuff with all kinds of firewall configuration in Linux, right? There's a bunch of like options here that you can take. But that means any server can go away, and you would only pay for a commensurate outage, right? So if one server out of 10 goes away in the Microrouter layer, the other servers just pick up the slack, and you haven't even lost any key. If one of the servers as a Memcache layer works, and if you configured your Microrouter very carefully, only 10% of your keys vanish temporarily. They'll get allocated to other servers, and eventually when that server comes back, they'll get reallocated to that server. It takes a while to configure all of that. But the thing is that this is a thing that like an ops team should do once, and eventually you have this caching tier. So because my talk is more focused on like the how to use caching from the application side for like web services, I assume that this is the kind of layer that you can expect, more or less. And let's think about how to use that kind of layer to do caching really well. So the first thing that you discover when you start writing code that uses caching, it complicates the code, right? Because before that, you had result equals send query to database. Here is a query, right? And that's code necessarily simple. I've seen pretty complicated queries, but the caching doesn't make the code go away, right? Now the cache is like get key from first, figure out the right key for that query, right? So you already have to calculate the query, figure out the right key for the query, go to the Memcache and see if you have a result there. If not, still go to the database and get the data and serialize it and put it in Memcache for the next time. So what used to be one line is now like easily 6 or 7 lines of kind of pure overhead from like a theoretical perspective. You're not getting any new features. Hopefully you're doing it for one of the reasons I outlined. Those 6 or 7 bugs, so 7 lines of code can potentially have bugs, right? Like any line of code, right? You can make a mistake in like any number of ways. And now you have more corner cases, right? For example, what happens if the query returns with too much data, right? Are you going to cache all the data? What if you're using partial amounts of that? So you might have to kind of do some data analysis before you do the send to the cache. Your code needs to account for them. Your code needs to account for all these new corner cases. What if the key is there, but the value is outdated? What if the value is misformatted because some other thing on your tier had a bug and saved incorrect data to the cache, right? There's all these corner cases. Your code needs to account for that. Your code needs to account for new failure modes. Your network can disconnect. You usually have a persistent connection to the Memcache because, again, because it's used a lot for latency, you definitely don't want to go through the TCP setup. every time. So that connection disconnect. Again, it's a weird corner case because it happens in the middle of like, you getting a key, or maybe you already got 3 keys and now it disconnected and you need to kind of handle that. So the network can timeout. Again, remember, it's used for caching. So you probably don't want to wait too long for response. So you probably want to configure timeouts. Now you have 2 ways things can go wrong. They can timeout or disconnect. Packets go missing, server go offline. There are all kinds of reasons why the network will give you timeouts. And of course, keys can be missing, right? In surprising ways, right? If someone reboots a Memcache server, reboots are pretty fast nowadays. The Microrouter might not even notice a blip in like the consistent use of it, but all the keys will be missing because Memcache is all in memory. Of course, keys can expire, and like I said, there's like a lot more ways that keys can go missing. Your code needs to account for all the ways that keys can be missing in the weirdest of times. For example, if you have 2 places where you hit the cache, it might be known to be missing in the first time and be missing in the second time. And lastly, ideally, that doesn't happen a lot, but the values can be invalid. Keys can collide if different things are using the cache. Ideally, again, you have some sort of convention around that, but you want to account for that potentially happening, and at least have a reasonable way to log that. And most importantly, if you're upgrading a version, the previous version might have had bugs because nobody is perfect, and might have already cached some things that now last for like, say, 3 hours. You're already done with your rolling upgrade, but you're still dealing with like the bugs from the previous version as you're dealing with the values. This is something to think about as you're implementing your cache. And the values can be outdated, right? That means like the value looks good, but the real world has moved on and things change. That again might be okay for like some amount of time. You have to figure out how your code handles that. As the intro to my talk has mentioned, confidence validation is hard. It's hard because it's balancing performance versus correctness, right? It's very easy to invalidate all the time, but then why cache? It's easy to never invalidate, but then you might be dealing with really bad values. So your code has to deal with that. You will need to figure out the expiration time. That depends on your needs in your code. And you want to put, like, the best practice here is not a specific amount of expiration. The best practice here is to stop writing code, right? Like, take your fingers off the keyboard, spend time thinking, and then maybe put your fingers on the keyboard, but switch to your Slack and talk to like other people and figure out what do we actually need. And then clearly document the trade-offs you've made, because I guarantee someone will have a different opinion. You can delete from the cache. That's a mixed blessing. Sometimes it makes sense, sometimes it doesn't. Again, you want to think clearly about what you're doing that. Caching servers are you're going to make the database fall over, or do you want to clearly fail and just not do anything? And here's the thing, right? These ways to fail will hit you when there's pressure, right? When everything goes well, your caching tier will probably function amazingly well. When it's pressured is when the things more fail, which means it adds complexity exactly for the use cases where you added the cache, but you will not see it until you're actually under stress. And this means that you want to start writing very, very careful tests. You want to test the cache hit path. This might sound trivial, but it's often missing unit tests, right? Because you're not going to write like 5 unit tests for the same situation, which means that you might be only hitting like that specific key value once, or you might be abstracting the cache completely away, which means you'll never actually like fall into the cache hit path, which means if you have a bug there, you'll only find it in production, because often even QA stuff doesn't find it, because again, QA will test with one user and then be done, right? They don't need to like refresh 5 times that user, right? Like they don't expect that this will be a different behavior, unless you tell them and you make sure that, whoever is running the test both end-to-end test and the unit tests is actually hitting the hit path. You want to test the cache mispath in realistic scenarios, right? Of course, it's going to be missing in the beginning, but you want to make sure that if there's a hit and then a miss, you're still kind of doing something correct. Again, it's very easy to write code that won't work that way. It's very easy to not unit test those cases. You want to test a bad cache value. If you update your software, can you detect that something was cached by an old version? So you can at least explicitly throw it away. If not, maybe you want to think about it right now and not after you have a bug. You want to test what happens when you disconnect. At any point during your conversation with the cache, there's probably a few times, right? What if you disconnect between the time you do a failed get, but before you do the set? You want to test what happens with the timeout. What is the worst that the cache can do to slow you down? Remember, you added it probably because there was a use case where the latency mattered. Maybe you don't want to make the cache be able to give you arbitrary latency increases if there's a problem with the cache, even if it's temporary. And finally, the next bit is right, let's say that you use the caches correctly. Remember that cache is an optimization. What does it mean to treat something as an optimization? Well, it means a few things, right? First, don't do it prematurely, right? But also, when you do it, is it helping? You want to measure the cache effectiveness. How helpful is it, right? You're paying money to run all these servers. Is it giving you the value that you wanted? You want to measure the hit ratio by code path, because otherwise it might be that the cache here has a really good hit-miss ratio, the cache here has a really bad hit-miss ratio, and you average out to like an okay hit-miss ratio, but that's not the reality. The reality is you should still keep that cache and you should probably get rid of that cache, which means every code path or object type or something should have its own counter for hit-miss ratio. And yes, counters are really, really good for that. You probably want to do on the back end, the analysis of like getting the difference and doing the ratio. So inside your code, you want to keep counters, and it's a monitoring aggregator. You want to start measuring ratios very carefully to make sure that if the effectiveness falls, you will know about it. Because what happens if like the usage pattern, changes? For example, someone caches in front of you, and you end up not getting a lot of cache hits, but you're still caching. That means you're at that point you're imposing pure overhead. That can change without your code changing at all. You want to make sure that you keep measuring that effectiveness throughout the life cycle of your code. You want to measure time histograms differentiated by hit miss. If you combine those histograms together, you're losing visibility into any potential problems. For example, maybe the thing that you're trying to optimize is so fast that the hit miss is the same. Right? If you combine them, you won't see that. If there isn't enough of a difference, maybe stop caching. Even if you get amazing hit rates, if they're not helping you, why do it? Which means you probably want to be able to turn on a dummy cache that basically always misses by just a configuration option that's like disable cache or dummy cache or something like that. That's super useful when you debug, right? It will completely eliminate a lot of potential cases, right? So it gives you an easy way to decide whether the bug is in the caching part or in not the caching part. It also gives you a good way to do A/B performance testing, right? You can set the dummy cache on and see if it actually matters. And sometimes if you need to quickly remediate problems, you can set the dummy cache on. Sure, you might be slower or you might be not managing the database well, but you might be surviving an outage that's caused by some problem with the cache. Again, I'm not suggesting you'll actually do that remediation when you get to the outage. You probably want to think, but I'm suggesting you keep it as an option on the table as you're writing the code and as you're building the basis of all the things. If you do A/B performance, you want to do it by key hash, not by server. The reason is because different servers, if they decide to kind of like if they have the same keys, then your AB won't actually be accurate. It will kind of aggregate weirdly. So if you do measure performance, you want to measure it by key hash. You want to decide very carefully what to cache. What is the granularity? Again, this is an optimization question, so this should be answered by measurement, but also by careful thinking. If you cache a lot, it might take more memory on the caching side, and which might evict other stuff. If you cache too little, you might have to go back and forth to the cache a lot. So you want to use both thinking and empiricism when you decide that. Remember that especially in the bigger sizes, caching can cause eviction, which means it sometimes is an anti-optimization to cache something else because it can evict other things. You want to make sure that you thought about what serialization you use at your cache, because serialization and deserialization have a performance cost, and you want to think about the trade-offs there. A lot of people use JSON, which is probably an okay option. Some people use Pickle. There's a lot to unpack there. If you do that, you probably want to use a signed thing, because otherwise you're opening yourself to a really weird threat model. When you open a socket to the cache, you want to configure the socket options very carefully. You might want to set up TCP no delay, TCP quick up, TCP cork. Those are very esoteric. I really don't have the bandwidth here to get into the details of socket options, but at least make sure that you have an easy way to check which of those actually improve things and how much. And probably spend some time reading up on TCP, because this can easily be a 10x difference in like the latency of the cache. You want to use MultiGate, right? You remember that MultiGate or get multi, or however you call it, depending on the specific interface you use, allows you to get a bunch of keys. Sometimes it would require a lot of subtle refactoring to do. However, if you go back and forth to the cache, you get a lot of network latency overhead. If you do that all in one go, you can, again, like if you cut it down by a factor of 5, again, that can speed up things immensely. It does mean that the application code needs to be refactored quite a bit. But often if you don't do that, just don't use the cache, right? And if you do decide that the optimization is worth it, actually go through the trouble of refactoring your code to figure out all the cache it needs ahead of time, or as much as possible, and then gets them. Here are a few things that I hope you'll remember from my talk. Caching is an optimization. Don't do it prematurely. And after you do it, make sure you measure it, and make sure you measure it continuously, because circumstances might change, and what was correct a while ago might not be correct, even if you don't change your code, just purely based on how the code usage pattern changes. Like any optimization you add, you want to test correctness, right? It's really easy to optimize code and make it less correct. That is probably not a goal you have, and you probably should prevent it. You want to monitor performance continually. You want to have alerts if the hit-miss ratio goes too much down, because that means maybe something is going on and you are not doing the right thing, and that can cause a problem. And you should always apply best practices, like setting the socket options correctly, setting the MultiGate, using MultiGate as much as possible, and so on. And so these are like the main points I hope you took away from this presentation. Thank you very much for being here and listening to me. And I hope that makes it, that remembering these things will make your cache usage much better. Thank you, everybody.